Electric motor. We use different types of electric motor for different robotics application or Arduino project based applications, and this comes in different variation of motor. In this video we'll learn about these basic types of motor and how to interface them with Arduino. So let's get started. In most of the electronics project we have basic three types of motor that we see or that we use for different applications. The first one is simple DC motor, the second category is servo motor, and the third one is a stepper motor. Now let's have a brief idea about these motors. The DC motor, these are basically used for various applications where continuous and reliable rotation is needed. Here accuracy is not confirmed or precision is not obtained. So this DC motor, they can be controlled for duration or speed. The servo motors are excellent for applications where precise positioning is essential. They can accurately control the angle or position of the output shaft. Whereas in a stepper motor, it is used where position accuracy is not critical. They move in discrete steps. About the range of rotation, DC motor, they does not have any constraint on rotation angle. They can have continuous rotation. Whereas the servo motor shaft, they can only move between 0 to 180 degree, and the stepper motor, they do not have any rotation angle constraint. They can move with rotation, but the step of rotation is discrete. So per step they move around 1.8 degree. Using discrete step, stepper motor works. If you want to know the application, DC motors are basically used for general purpose fan, cooling fan or conveyors, application like that. Whereas servo motors, these are basically used for robotics hand, CNC machines, camera gimbals and applications like that. Stepper motors are also used for 3D printers, CNC machines, where angle based controls or discrete controls are used. Also in hard disk, this type of stepper motor can be found. According to the application requirement, we will choose among this any of the motor. Now let's talk about the first type of motor, that is the simple DC motor. In this video, we'll restrict our content to DC motor control only. In the upcoming video, we'll cover the other motors like servo or stepper. Now the DC motor, they have two terminals. One is for VCC or positive power and another one is for ground. With this DC motor, we have two types of control. The first one is direction control. It can move clockwise or anti-clockwise. And the second type of control is about speed control. You can control what is the RPM you want to obtain here using PWM pulse. So the direction control it's a pretty simple concept. Let's say we have a 12 volt DC motor and we want to run this motor at full speed, but you want to control the direction here. So if you are looking for clockwise direction, you should connect 12 volt at one terminal and 0 volt at another terminal. For anti-clockwise direction, you just need to swap this connection at the power terminals. With this swapping configuration, we can change the direction of the motor rotation. But if you are looking for variable speed, then you need to apply PWM at the terminal of VCC. Now let's have a brief idea about PWM. What does it mean? Let's learn what is PWM. PWM basically stands for pulse width modulation. So here we obtained analog equivalent value using digital signal. And we know Arduino cannot directly generate an analog output or analog voltage. We will apply PWM concept to generate that equivalent analog voltage using PWM. So PWM is basically turning a switch on and off very quickly. By doing so, we can adjust how long the switch is on, and we can control the average amount of power delivered to the load. So this is the key point. Okay. Here's another concept is related, that is duty cycle. It is nothing but the on time ratio to the full time, that is on plus off time. And with the percentage, we express this duty cycle. And what is on time? Let's say here's a digital pulse. The time it is on, this is called the on time, and the time it is off, it is called the off time. With an on and off time, it becomes a complete cycle, and the time required for a complete cycle to complete, we call it time period. Okay, so now let's understand the concept of getting equivalent average value from PWM. Let's say we have a 5-volt source. Now if you want to obtain 0 volt, you need to apply 0% duty cycle. That means the pulse will remain at 0 level, there will be no pulse. At that time you will obtain 0 volt. If you want to obtain the full 5 volt, then what we will do, we'll keep the output at 5 volt and there will be 100% duty cycle. It will result in 100% duty cycle. So if you keep the output voltage at the 5 volt level, you will obtain 5 volt. If you keep it at 0 volt, you will obtain 0 volt. What if we keep the power on for 25% time and off for 75% of time? This will result in 25% duty cycle, and the average value of the output, it will become 1.25 volt. Similarly, if we keep the duty cycle at 50%, that means half of the time period it will remain on and half of the time period it will remain off. So this will cause average value of 2.5 volt, that is the half of the total voltage of 5 volt. Similarly, if you keep the source on for 75% time, that is for 75% of time period it will remain on and 25% time it will remain off, this will result in a equivalent voltage of 3.75 volt. This is called the average voltage. And how we get this? The 75% of 5 volt is 3.75 volt. So this is the basic concept. We are using digital pulse and we are obtaining an average value or average voltage from this signal as an analog voltage. So this is how the PWM concept will work. The function we will be using for generating this sort of PWM is analog write. Now if we use analog write and 255 value of output, then it will request for 100% duty cycle. And if you put the half of 255, that is 127, it will request for 50% duty cycle. Similarly, here we can see for 0 volt, analog write 0. For 25% of output, we can write analog 64, which is 1/4 of the 255. Then for 50% duty cycle, we can write half of the 255, that is 127. For 75%, we can write analog write 191. And for 100%, we'll use analog write 255. Remember, the syntax for analog write is first analog write, we will have to write that, then the pin number, then these values. Let's talk about how we can interface DC motor with Arduino. In previous applications like LED and Arduino, we connected LEDs directly with Arduino board. But in case of DC motor, we cannot do that directly. That's because the output current of an Arduino digital output pin is typically limited to 20 to 40 milliamps. But the LED, when we used LED directly to the Arduino board, the output current for a typical 5mm LED, and it falls in the range between 10 milliamps to 20 milliamps. So that is why connecting an LED with Arduino board was safe. But for a small to medium-sized DC motor used in hobbyist and low-power applications, we can often find motors with current rating in the range of 100 milliamps to 1 ampere for full speed operation at 5 volt. And it can vary depending on the torque required and the applications we are working on. So, as the Arduino board output from digital pin is limited in between 20 to 40 milliamps, whereas our DC motor requires 100 milliamps to 1 ampere, so we cannot connect a DC motor directly to the pin of the Arduino. It will burn the Arduino board out. So that is why we need something in between, that is called motor driver. So this motor driver will receive signal from Arduino. It could be DC signal like 5 volt or ground, or it could be PWM pulse. So in accordance with the input from Arduino to motor driver, it will connect external power supply and drive the signal, similar signal for the DC motor. So that's the function of motor driver. It does not generate new signal, but it bypasses the power supply to this DC motor using the Arduino signal from external power supply that is suitable for this DC motor. I hope you got an idea why we need motor driver. There are several types of motor driver available in the market. Let's see what's the most common one. The board we have on the screen, it's L298N model. So this is a common type of DC motor driver. Here you can find out the pin out and the pin description. Like at the top we have IC. This is the IC L298N model of motor driver IC. As it is a semiconductor chip, this can generate high temperature. That's why we are using a heatsink. This is basically an H-bridge IC. We'll explain what is H-bridge IC in details. Now, there are some other components here. The driver power input, the motor driver will take some power like VCC, ground, and the input from the Arduino. So this rail of pins, this will receive that signals and the input power. Now, you can drive two motor with this module. This left rail, this controls the motor 1, and using the right rails, you can control the motor 2. If you want to use 5 volt for the DC motor, you can enable using this 5 volt jumper. So here's a jumper, this is removable. Using this, you can enable the 5 volt supply. To ensure the 5 volt, here's the 5 volt voltage regulators also. So I hope you got the idea about the pin out of this motor driver. If you are working for single motor and if you don't want to use the motor driver, you can use relays also. Here the relay will receive signal from Arduino and the power will be supplied from an external voltage source using the relay output NO-NC contacts with the DC motor. So this is also another configuration you can use for DC motor. In the next video, this video is getting long. This will be part 1. In the next video, we'll learn how we can apply this sort of circuit to a simulator using a simulator. In the next video, we'll learn how we can use this sort of applications. Okay, that's all for this video. Thank you.